In this video, we're going to look at contingency tables and marginal distributions. In this particular example, we have a contingency table, and sometimes a contingency table is called a two-way table because a contingency table or a two-way table has two variables. It has a row variable and a column variable that's showing information. In this particular table, we are looking at data from November of the year 2018 that is showing both employment status and level of education for U.S. citizens who were 25 years old and older. So from this table, we can see the value 9,607 in this category here. It's in row 1, column 1, which is employed and did not finish high school. So 9,607, and these data are actually in thousands. So this is 9,607,000, which really means 9,607,000 U.S. residents aged 25 and older who did not finish high school and were employed in November of 2018. There were 34,625,000 individuals who were high school graduates that were employed. 36,370,000 U.S. residents who had some college and were employed. 57,102,000 individuals who had bachelor's degrees or higher and were employed, and so on. Row 2 shows unemployment status by level of education, and so on. So we have lots of information provided in this contingency table. Again, information about both employment status and about level of education. So we're going to be looking at these types of tables for the remainder of this section. A marginal distribution of a variable is a frequency or relative frequency distribution of either the row or the column variable in a contingency table. So if we look again at our table, if I want to create a marginal distribution, we can either make a frequency marginal distribution or we can make a relative frequency marginal distribution. So let's look at an example. Using the data below, which is the same data that we looked at before for employment status and level of education, A, find the frequency marginal distributions for employment status and for level of education. B, find the relative frequency marginal distributions for employment status and for level of education. So if I want to find the frequency marginal distribution for employment status, then all that means is that I need to find the totals for each row, which is talking about the employment status. So if we add up 9,607, 34,625, 36,370, 57,102, if we add that up, that will give us the total here, the total frequency, and that adds up to 137,704. So adding that up, 137,704. If we add up the 570, the 1,274, the 1,170, the 1,305, that adds up to 4,319. And if we add up the 11,662, the 26,426, the 19,864, and the 20,841, that adds up to 78,790. So this is the marginal distribution for employment status. Now again, these data are really in thousands. So there were 137,704,000 U.S. citizens aged 25 and older who were employed in November of 2018. There were 4,319,000 individuals who were unemployed, 78,790,000 individuals who were not in the labor force. So this is the frequency marginal distribution for employment status. Now, if we want to find the frequency marginal distribution for level of education, then we're going to find the totals for the columns. So if we add up the 9,607, the 570, the 11,662, that adds up to 21,839. If we add up 34,625, 1,274, and 26,426, that adds up to 62,325. If we add up 36,370, 1,170, 19,860, that adds up to 57,401. And if we add up the 57,101, 1,305, and 20,841, that adds up to 79,248. So this is the frequency marginal distribution for level of education. In November of 2018, now again, these data are in thousands, so there were 21,839,000 individuals 25 and older who did not finish high school. There were 62,325,000 individuals in November of 2018 who were high school graduates. There were 57,401,000 individuals who had some college, and there were 79,248,000 individuals who had a bachelor's degree or higher. So this is the frequency marginal distribution for level of education. So these are the answers to Part A. This is, again, the frequency marginal distribution for employment status. This is the frequency marginal distribution for level of education. Now in Part B, we want to find the relative frequency marginal distribution for employment status and for level of education. So all that means is that we're going to change these into relative frequencies. So we're going to take each one of these values, each one of these frequencies, and we're going to divide by the total. So we have to figure out what is the grand total. How many individuals are represented in this table? So we could figure that out two ways. One, we could add up the 137,704, the 4,319, and the 78,790. If we do that, that gives us 220,813. Now we'd get that same result if we add up the 21,839, the 62,325, the 57,401, and the 79,248. So if we add up these four values, we get the same total. So again now, if I want to find the relative frequency marginal distribution, so I'm going to do the relative frequency marginal distribution. So if I take 137,704, now again that's thousands really, and if I divide by 220,813, again that's thousands really. So taking this divided by this, I get approximately 0.624. So that is the relative frequency for employed. If I take 4,319 and divide by the 20,813, that gives me approximately 0.020. And if I take 78,790 and divide by the 220,813, that gives me 0.357 approximately. Now if I add these up, because these are the relative frequencies, they should add up to be 1. In this case, because of rounding, it doesn't add up to be 1 perfectly, but without rounding, it should add up to be 1 perfectly. So what is this telling me? This is telling me that the relative frequency for employed is 0.624. The relative frequency for unemployed is 0.020, and the relative frequency for not in the labor force is 0.357. So in other words, about 62.4% of individuals in November of 2018, aged 25 and older, about 62.4% were employed. About 2% were unemployed, and about 35.7% were not in the labor force. That is the significance of this relative frequency marginal distribution. Now I can do the same thing for the level of education. So I'm going to find my relative frequency marginal distribution. So if I take 21,831 and divide by 220,813, that would be approximately 0.099, again rounding to 3 places. And if I take 62,325 and divide by the 220,813, that would be about 0.282. 57,401 divided by the 220,813, that is about 0.260. And if we take 79,248 and divide by 220,813, that is about 0.359. So again, the relative frequency for did not finish high school for the year for November of 2018 is 0.099. The relative frequency for high school graduate is 0.282. For some college, 0.260. For bachelor's degree or higher is 0.359. And again, without rounding, if I add these up, that should add up to 1. So again, what's it really mean? About 9.9% of U.S. residents aged 25 and older in November of 2018 didn't finish high school. About 28.2% were high school graduates, 26% had some college, and 35.9% had a bachelor's degree or higher. So this is a contingency table, and this is the idea of a frequency marginal distribution and a relative frequency marginal distribution.